Hi everyone, this is 1214 College Physics 2 course. My name is Emrah Turgut. So today we will start chapter 18, but before starting the material, I would like to answer some of the frequently asked questions. So there are three parts for this course. First part is the lecture, and it will be asynchronous video recordings like this, and you can watch anytime you want. It's not gonna be live, but we will have office hours for live interaction with students. The second part is the lab. From the syllabus, you may see that the lab is 25% of the course, and it's in person so far. So you need to know your lab section, and each of you is registered a specific course number depending on lab section. And we will have discussion hours done by teaching assistants, and it will be synchronous. So we will post the schedule for that on Canvas, and you can ask your questions to TA, and they will also solve some problems related to material. And you can go to any of those recitations, discussion hours, but they will be solving the same problems. So, and it's not an easy way of learning. So you have to watch these boring videos of physics. So I try to be as fun as possible, but I am recording this lecture in my office, so trying to be fun by myself is not very easy. I cannot laugh by myself. And also, is it difficult for you? Also, it's difficult for me. I will be stuck in my office, just being a lonely professor here. So, but it's what it is. So let's try to be positive and get the most out of this course for you, and in the future will be useful for you. So, okay, then we can start the lecture. So we will start, I will share my iPad screen and write on it. Okay. So you should have seen this book before, because using the 11-14, I guess. And now the 12-14 is gonna continue from chapter 18 until the end. And the first chapter is electric charge and electric field. Okay, the purpose of this course is to understand the electrical charge, conductors and insulators, Coulomb's law, and to be able to solve some problems. And as you see in the picture, the goal is just take a stick and rub yourself with the hairy part, and you will see that it will attract some papers, pieces. So it comes from the electricity. And these are some important questions we will try to answer. And these questions are kind of important to think in future exams. Okay. The static electricity is an excess of electrons or protons. And what happens is, like, when, for example, when you have a kid slide through that park and a plastic, because of the rubbing, it the kid exchange electrons, and because of the imbalance, the kid is charged, and you can see the hairs pulls each apart and get spiky. And one interesting factor about the name of electricity and electron, where it comes from. So actually it came from this ancient rock. We still have it, but in early days, people use amber, and they saw it attracts the objects, and the name of the amber is electron in Greek. So then electricity, the word of electricity came, and amber is a very let's say stable rock, and when you rub it, it doesn't lose an electron, but other objects have lose electrons, and the amber can attract electrons from them, and it gets charged. And when you approach a neutral or other the charged particles or objects, it can attract or repel. That's a fun fact about the origin of the electron. So more relevant example about electricity is the demonstration done by Benjamin Franklin. So actually he was a very unusual person. He was interested in electricity. He did this kite experiment. Also, he used to give the electricity to give shocks, give people the shocks, and etc. And at that time, the people are trying to understand the origin of the thunder, and they had some ideas, but then Franklin came and explained it. And also, he was really an inventor, so we still use the lightning rod made by him. We still use the same design, and he also used the terms battery, charge, condenser, and conductor. So what the founders for the country. This is a great guy. Okay, for the how the electrons are shared between the amber and cloth. So for example, at the beginning, you have a nut, amber and cloth, and when you rub them, the amber the electrons in the cloth are loose, and what happens is the electrons are transferred to amber, and at the end, in the amber, this is just example, you have 2 positive and 4 negative, then you have -2 as a charge. In the cloth, you have +2, and unlike charges attract each other, so that's why the amber is gonna attract the cloth. So in microscopically, in the elements, we have protons and neutrons in the nucleus. So the protons are positively charged, neutrons don't have any charge. And around the nucleus, we have electrons, and electrons are negatively charged. And in neutral atom, the number of electrons is equal to the number of protons. So it means the atom is neutral. And when the elements lose or gain electrons, they can have chemical interactions and make bonds. And another factor is the protons and neutrons are much heavier, so the electrons are much lighter. That's why we see the electrons are moving, the protons and neutrons are stationary. That's also true in electricity. The electrons move, protons and neutrons don't move. Okay, so in SI unit, the unit of charge is coulomb, and the one electron has 1.602 times 10 to minus 19 coulomb charge. So the electron charge is quantized. It's the unit of the charge. And usually in our lectures and exams or homeworks, we will talk about micro, milli, nano coulombs. So that's why it's good to know. The micro is 10 to minus 6. Milli is 10 to minus 3. Nano is 10 to the minus 9 coulomb. To detect the static electricity, we use electroscope, and just for the demonstration and learning labs. Before inducing any charge in the electroscope, you have a neutral leaf, and because of zero net charge, they don't repel each other. It just as a stationary, like the zero angle between them. And you have a metal rod connects to the metal plate. What we have is this is a glass bottle. The air is taken out, because when you have an air, because of the interaction, you can lose electricity and etc. But having a vacuum is gonna help to keep the electricity and then observe the motion of the leaves. So in a typical experiment, you bring a positively charged rod with the black one, and the positive charges attracts the negative charges, and the negative charges gets more and more at the top. You have more electrons there, like excessive electrons. And on the other hand, on the leaves, you have less electrons, which means you have more protons. It's positively charged. And because of that charge, the leaves are gonna start to repel each other because they have the same charge, the positive charge. And then you can see that if the rod is charged or not. So in the case of in the example, electrons are moving because electrons are light. In the conductor, this is a conducting metal called leaves and so on. Electrons, they have metals, and conductors have 3 electrons. The electrons can move freely, and that's why they come to the top metal plate due to the positive charge, and it goes down. The protons are gonna be more on the leaves. Okay, the conductors, usually they are metals. The metals are good conductors, and the charge moves easily through the conductor. In insulators, electrons are tightly bound, and they cannot move freely, so insulators don't carry a current, but they can be charged. So that's important to know. They don't move the electrons freely, like in metals, but they can have charges. They don't have to be neutral. So in semiconductors, they have small electrons, and depending on the voltage we apply on them, they can be conductor or insulator. So these semiconductors are the basis of like semiconductor technology, like transistors and so on. So charge movement by conductor. So for example, we have an example. For example, we have this illustration for the movement by conduction. So you have a charged plastic rod and you connect with the copper wire. The copper is conductor, so it can pull the electrons from the charged plastic rod, and it can bring the metal ball. So if you take out the copper wire, what you have is negatively charged metal ball and the negatively charged plastic rod. Because they are both negative, they will repel each other. And as you see, and if you bring another positively charged rod to the metal, because the metal is negatively charged, it will attract. Okay, like charges attract, unlike like charges repel, unlike charges attract. Negative charge, positive charge, they will attract. If you have two positive, they will repel. If you have two negative, they will repel. Another scenario is charging by induction. So in this example, you have two metal sphere ball on an insulating stand. So they don't touch each other, although they touch at the beginning, but they don't touch the ground. So you bring a positively charged rod, and these two are connected. What happens is this positively charged rod attracts the electrons, and they come to left-hand side. Because of that moment, the right-hand side will have less electrons, means positively charged. When you disconnect the spheres and remove the rod, what you will have is you will have negatively charged ball at the left and right, at positive at the right. Because of these attraction, the negatively charged electrons are going to come to this side of the ball, and the electrons are going to push this side. So the left-hand side of this second ball has the positive side. So because of the attraction, the charges are going to get closer. Another example for charging by induction. The induction, in this case, you don't touch it. I mean, the rod doesn't touch the sphere. That's the idea. So for example, in this figure, you have a rod positively charged and neutral sphere. So what you have is, because of this attraction, you have negative charges at this side and positive charges on the right-hand side. Then you ground it. Ground is a charge reservoir, is an infinite reservoir. You can take as many as you want, or you can dump as many as you want. So the ground is usually zero, like the balancing factor. So what happens is, here when you have too much positive charge here, you get more electrons from the ground when you touch this right-hand side to the ground with a conducting wire. So because of that balancing act, the electrons are going to come and nudge this side. And side will be nudged. So because of that, you lose all the positive charges on the right. And if you take the disconnected ground, what you have is just negatively charged ball, sphere. And if you remove the rod, take it far away, then there's no electric, or there's no charge around, so the electrons are going to distribute it uniformly around the on the surface of the sphere. And so far we saw examples on conductors. I mean, they can move the charges freely, but in insulators, the case is a little bit different. You still can have polarization, which means that you can have positive or negative charges on the one side and the other side, the charges on the other side because of the polarization. Compared to conductors, they don't have too much charges. For example, in the metals, conductors, you can accumulate a lot of charges on one side, another side. But insulators, you can polarize the material. So for example, if you see this example, for instance, in this example, you have a notch insulator. It has the same number of electrons and protons, but when you bring a positively charged rod, what you do is you polarize. You bring the negative charges to the left side, like rotate, and the right, the positive charges. So if you do this for all the atoms or molecules in the insulator, then what you see is this left-hand side is negatively charged, the right-hand side is going to be positively charged. Again, you don't change the total charge in the system. It still has the same electron and number of electron and proton. But what you do is you move, you polarize, you rotate. At the end, you have some excessive electrons on the left side and excessive protons on the right side. That's how it looks like. If you bring a negatively charged rod, opposite is going to happen. You will have positive charges on the left and negative on the right. So what happens is, again, it will attract because you have a negative charge here and positive charge closer to the negative charge. And this is far closer. So because of being closer, it will have a more stronger force and it will attract more than it repel the negative charges. That's exactly what happens when you have the charge rod or the comb. When you bring the paper pieces it polarizes. The paper is not conductor, it's insulator. So what happens is if the COM is negatively charged, you have positive charges closer to the COM, and it will pull, it will attract. And for the positively charged COM, it will attract the negative charges. Because of the polarization, you can still apply forces. This is another example. Right now we have positively charged sphere on insulator stand, and you bring a neutral ball. What happens is that the sphere A polarizes the metal, and you have negative charges closer to the sphere A, and the pulling force is stronger than F pushing force for the positive charges. At the end, the net force is going to be non-zero, and it will pull the ball. These are some terms. Electricity we use when electrons are stationary, or it's a very small movement. Electrostatic, electric charge at rest. We have two charges, positive and negative. Like charges repel, opposite charges attract. We talk about conductors and insulators. We talk about charging by conduction, charging by induction, and grounding. For the ground, you can take as much as you want, or you can give to balance it balances the charges. The ground is neutral, so when you touch it, you will get neutral. You will become neutral. You will lose excessive electrons or protons. Now we have examples. In the first example, we have a metal ball on an insulating stand, and we will charge by induction. And how it's, and the question asks which of the following happens. So let's try to understand the example. So you have a, let's say, a positive charge rod, and you bring to a metal sphere on an insulating stand. So which means that the metal ball doesn't take any charge or give charge. So do we have options A, B, C, D? It says charge on the ball changes while the charge on the rod stays the same. B, charge on the rod changes while the charge on the ball stays the same. The charge on the both rod and the ball changes, or neither changes. Okay, what happens when you bring this positive charge rod, you have negatively charged charges on the left-hand side and positive charges on the right-hand side. So rod is insulator, right? So it doesn't move the charges that much. But what happens in the metal ball, you move the charges, and the left-hand side becomes negatively charged and right-hand side becomes positively charged. So actually the question is not very clear, maybe to some of you. The total charge, number of total electrons and the protons don't change, but you still charge you move the charges on the ball. So then you will say the ball, the charges on the ball changes, which means they move. and on the road stays the same. So, but the question was asking about total charge. It will not change for the ball. Now we have another example. We have two balls. They hang from the ceiling. And as you see, they repel each other. And the question is, what can you say about their charges? So you can pause and solve the problem. Because of repulsion, the charges, the balls must have the same kind of charge. So both are positive or both are negative. A metal ball, another example, a metal ball hangs from the ceiling by an insulating thread, means the ball doesn't touch the ground. The ball is attracted to positive charged rod near the ball. What's the charge of the ball? So if this is, you can pause if you want. For this example, you have a positively charged rod and it will attract. So the attraction happens in two ways. First, if the ball is charged, so for this it must be negatively charged, right? Another way is by polarizing. The positively charged rod, if the ball is neutral, it will attract negatively charged this side and push the positive charges to right hand side. So the pulling force is going to be stronger than the pushing force. So the ball, if the ball is neutral, it still attract. So it's either negative or neutral. Okay, another example. You have two neutral conductors and we connect them with a wire. It's a conducting wire. So when you bring a positively charged rod, you induce some charge, you don't touch it. With the rod, you induce charges, and then you remove the rod and the cable, the wire. What's the final arrangement of the charges on these balls? You can pause. So for this case, what we need to do is, if this is a positively charged rod, what is the charge on the red ball? It's going to be negative, right? It will attract the negative charges and repel the positive charges. So when you cut the wires, they don't exchange charge anymore. You will have still negative charge on the red and positive on the blue. And the answer is going to be 3. So that's all for today. Tomorrow, I will have office hours not at 8:30. I have an appointment. I had to move to 11 or 11:30. I will post that on the canvas. So if you have any question, please feel free to ask. Again, yeah, it's best to have interaction with the students. I really like to see your faces and hear your questions. And then please don't hesitate. Take care. Have a good one.